Hello again, guys. I hope yesterday went okay with your graphing. Remember, if you guys need help, I'm obviously not there. You can always ask a substitute teacher, or please ask each other. I promise you, at least one of you understands what's going on at all times of the day. So, as we move on, now we're going to look at the transformations of these exponential functions. Once again, can be done by hand or on the calculator. It's completely up to you. Just make sure that you understand what we're doing. So I'm going to start with a really simple one, and we're going to do y equals 2 to the x. And the main thing that I want you guys to remember is that no matter how difficult something seems, it's always piece by piece. And we've already done a lot of it as is. So let's start with y equals 2x. Now, as we saw yesterday, we have two options. I can either graph it on the calculator, or I can graph it by x and y chart. And as we all know, I will be graphing it by x and y chart. The main thing that I want you guys, let's move the line down here. The main thing I want you guys to remember today is that if you graph through a calculator, you have to anchor your points. Do not forget to anchor your points. So I'm going to start with -3, -2, -1, 0, 1, and 2. And 3 down here. Okay. 2 to -3. Pop that into the calculator, and you get 0.125. 2 to the -2, 0.25. 2 to the -1, 1/2. And when I come in to do 2 to the 0, as we know, it's always 1. 2 to the 1 is 2. 2 squared is 4. And 2 to the 3rd is going to be 8. And now I graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. -3 gives me 0.125. -2 gives me 1/4. -1 is going to give me 1/2. 0 will give me 1. 1 is a y value of 2. 2 is a y value of 4. And 3 is a y value of 8. And I draw in my graph. And this is my standard y equals 2 to the x. Now, what happens if I want to write and graph this equation? What do we remember about transformations? We remember that on the outside is my 1. So my 1 has to affect my y. And since it's on the outside, I'm going to move which way? To the right or to the left or up or down? I hope you guys all remember it is going to be up. So I do 2. Same exact graph, but now I want to graph it up 1. So I graph all my points that I had so far anchored, and I'm going to pull them up. So this comes up 1. This one comes up 1. Right here. This is going to come up 1. This comes up. And I'm a little off on this last one. This one right here, which is at 2, will come up 1 point. And every one that I see, I'm going to bring up exactly 1 point. And I get my new equation. Nothing too difficult. So far we've done one kind of transformation. Let's do another one. What if I tell you I want to do same base. So I come in and I draw my same numbers. At 1 I had 2. And I get, this was my original. What if I want to draw a negative 2 to the x. Now, negative 2 to the x means that we're going to flip it across the x-axis. This means that every value that I had before will now come down to the x value. So this comes on this side, this one comes on this side, this has to come here, and so forth. Where 2 was at 4, now it's going to be at negative 4. Where 3 was at 8, now it will be at negative 8. And I get my new equation. When we do these transformation, guys, just remember your main rules. These can be found on the PowerPoint. I don't know if you guys remember. Your PowerPoints are on Edline. If not, here's a little version of it. When I do my vertical translations, it will be on the outside. Remember, the outside only affects the y. My horizontal will be on the inside, as in it will be attached up here to where the x is. My reflections will be negative, either up and down or right and left. And then I have vertical stretching and horizontal stretching. The main thing I want you guys to remember is that each one of these we have already done. So let's look at one more type of transformation using the same exact equation we've done so far. Okay, so I start with the same exact motion as before. I draw my original equation, and I go. It's a little off right here, but that's okay. Now, the equation I want to do is this. Now, it is not a vertical transformation, but it is going to be... Okay, give me 1 second, guys. I picked the wrong color. It is going to be a horizontal transformation, so we know that it's plus 1. And we know that for x is the only one where if it's plus 1 here, it's going to be the opposite. So instead of moving everything to the right, I will be moving everything to the left one. So this has to go here. This one goes here, here, and here. This here, this one moves here, and this one moves over one more. And I get my new equation. Okay, so this is the first half of today's lesson. I want you guys to pause the video, and I want you to go ahead and do your practice, which is transformations of exponential. So we move on to the next part of today's little lesson, which is compound interest. Now, we've seen interest in a couple of ways already. We did annual interest and simple interest, but now we're going to look at compound interest. So what compound interest actually means is that the interest is added on more than once a year. The way that this occurs is that every so many weeks, months, days, depending on what it is, they look at the amount of money you have and they pay you your interest on it. And then that interest gets added to it, and then the money continues. So it's a little bit different than the interest we had done before. And what we're going to use with it today is an equation that you guys have definitely seen before, but we will review just in case. So my equation is A equals P 1 plus R over N and T. Now I kind of want to break down the equation a bit more before we go into examples. Now A is the amount of money I'm going to get, total. And P is the principal that I'm putting in. So what does that mean? It's the first amount of money that I have. And then we have these three letters left, R, N, and T. Well, by now, you guys all know that T is time. Right? So this is going to be the amount of years that we have. N is how many times it occurs per year. And I'll explain that a little bit in a minute. And then R is your rate. How much money am I getting? No problem. So if I look at an example on how I do, so here's an example here. Find the accumulated value of the investment of $15,000. So this is my principal. This is the original amount of money that I'm putting in. For 2 years, so this here is my time, it's how long I'm going, at an interest rate. And here's my rate. If the money is compounded semi-annually, quarterly, monthly, and continuously. So let's start with semi-annually. What does it mean to be semi-annually? So semi means 2, so it's going to be twice a year. So if I look at my equation, so far I know a lot of the variables. So I know that P is $15,000. And my rate was 3.2%, which is 0.032. You have to convert to fraction. You have to convert. Do not forget to convert to either a fraction or a decimal. It's very important. My time is 2 years. And my n is the number it happens a year. Well, if it's semi-annually, that means that it's twice a year, so it's 2 times. So I go ahead and plug everything. A equals, well, I'm going to do it down here so we have enough room. A equals $15,000 plus my rate over twice a year times 2 times a year for 2 years. And this, you could just plug in your calculator. I would simplify it a little bit, but that is completely up to you. Depends on how you are with the calculator. I would do the parentheses first. So I would do 0.032 divided by 2 plus 1 gives me 1.016. And 2 times 2 is 4. And I would put that into my calculator. So 15,000 times 1.016 to the 4th. Gives me a total amount of $15,983.29. And this is the total amount of money that I have. Now, that was semi-annually, right? So semi-annually meaning twice. What if I want it quarterly? So I start again. I now know all of my numbers except for n. And now I want it quarterly. Well, what does quarterly mean? Quarterly is going to be 4 times a year. So if it's 4 times a year, that means it occurs 4 times that year. So I go back and I plug in 4 for my n. And I do the same exact thing that I did before. I'm going to simplify the inside just because it's easier on me. I get 1.008 over 8. And I plug that into my calculator. And I get a total of 15,987.31. Now that's quarterly. What if I want it? What was the next one? Let's see. Monthly. Well, what does monthly mean? Monthly means it's going to occur once a month. And there's 12 months in the year, so that means it will occur 12 times that year. So I put that in. Over my 12 months times 12 times 2 years gives me 15,000. Which is 1.0026 repeating to the 24th, which gives me a total of 15,990.33. Sorry. Okay, go ahead and do your worksheet, and